In this quick review of divergence test, we want to talk about if how to pick if something diverges right away by the divergence test. Now that doesn't mean that all of these converge or diverge, but we're only going to look at the divergence test. If you recall, the divergence test says what you should check right away is, does the limit as n goes to infinity of the sum equal 0? If the answer is yes, keep going with more testing. If the answer is no, you're done. You know, it diverges. Okay, so let's maybe start here. Okay, if you ignore this for a second and you just say, well, I'm ignoring this and I'm just thinking about the limit as n goes to infinity. Well, the high power on the top is n, the high power on the bottom is n squared, so the limit is 0. So I would need more testing. That doesn't mean it converges, it just means it doesn't diverge. Okay? The limit here as n goes to infinity is 0. More testing would be needed. Okay? The limit here. By the way, none of my notation here is good. I shouldn't be crossing the thing out, but it saves me from rewriting it. You'd need more testing. That leaves us with this top one. Now, we don't know much about factorial. You don't play a lot with factorial in other classes, but this gets very, very large very quickly. And I want you to think about the algebra here. In this, you're multiplying by a 2 every time. Okay, 2 times 2 times 2, you're multiplying by another 2. Factorial says you're taking, if n is 100, you start at 100 and multiply it by everything below it. So 2 to the 100th has 100 2's. 100 factorial has 100 numbers, 97 of which are, or 98 of which are bigger than 2 being multiplied together. So the top is much bigger than the bottom. So the limit, if n is going to infinity, is infinity. So this, only this one, diverges by the divergence test. All the other ones you would need more testing to know for sure.